The central console of the CTS is located in the cargo control room. The computer continuously receives data from the gauges and sensors mounted in each cargo tank. The cargo tank level gauging systems are the heart of the system. Each cargo tank is fitted with two independent level measuring systems, as this measurement is critical. Mostly the primary system uses a radar gauge, while the secondary system uses capacitance-type gauges. The central computer continuously receives signals from the primary level gauges, using which it automatically calculates the cargo volumes in the tanks. The system uses the signals from the tank temperature sensors, tank pressure transmitters, and ship's inclinometer to make corrections to the calculated volume. Operator stations. They are connected in a network to provide several operator consoles at different locations on board. Reports on failures and alarms are readily available. History and trend reports on CTS level, volume, vapor pressure, and temperature can be generated for a specified period. The operating station consoles display the measured values relating to the CTS. The operator can generate reports at the start and end of cargo loading or discharging. It can also be enabled to enter the values manually. If the automatic sensors fall, the reports generated from the display are saved on the hard disk of the computer. Printouts can be taken as desired. The reports should contain the name of the master, the surveyor, and the chief officer or cargo engineer. DCS interface. CTS provides continuous input to the ship's distributed control system DCS, which is used to monitor and control the cargo operation. During loading, the input from the level gauging system is used to control the tank filling rate. The primary level gauging system initiates the alarms for tank low level and normal filling level. It also sends a closing signal to the tank loading valve when the designed normal filling level is reached. The secondary level gauging system normally uses two independent high-level sensors of the capacitance type. One sensor is fitted at a level slightly below normal filling level to initiate an alarm. The other sensor is fitted slightly above normal filling level to provide a signal to the emergency shutdown system. Inclinometer. An inclinometer is used to measure the trim and list. The measurement principle is that a suspended mass within the inclination detector moves from a center position when the ship's trim or list varies. The inclinometer is installed in the electrical equipment room. The sensing element is a galvanometer pendulum associated with an optical position sensor. The movement of the pendulum is converted into an electrical signal, which is fed to the CTS interface. The readings should be checked against draft marks in calm weather periodically when alongside. As the response is set to 0.5 seconds, the system cannot give reliable readings underway. Radar type measurement. The radar tank gauge, RTG, consists of a microwave antenna with a transmitter and receiver, and an interface to the signal processing unit, SPU. One SPU is connected to each RTG. The SPU supplies intrinsically safe power and receives signals from the RTG and vapor pressure sensors. The SPU is located in the system cabinet. Gas-vapor density and mixture of gases influence and cause differences in the propagation speed of the radar signal, thus the accuracy of the measurement. Measurement accuracy is plus or minus 7.5 mm over full tank height. Capacitance type measurement. It measures over the total tank range with higher accuracy over the top and bottom and reduced accuracy over the mid-range. Each tank contains two multi-segment coaxial sensor columns extending to the full depth of the tank. One acts as the main level sensing column and the other as the backup. Each column is a capacitor with a dielectric of methane gas. As the tank fills, the gas is replaced by LNG with a higher dielectric, and the level can be determined by the change in the capacitance of the segment. Normally these sensors placed at a minimum of 5 levels, with 2 sensors at each level, one working and the other on standby. Measurement accuracy is plus or minus 7.5 mm over full tank height. Vapor pressure and temperature measurement. The pressure transmitter is used for accurate measurement of the cargo tank vapor pressure. The pressure transmitter comes with control valve with test flange and closing ball valve. Typical accuracy of pressure measurement is 1% of span over the range 800 to 1400 millibar. Each temperature sensor is connected to an intrinsically safe field bus with intelligent network modules. Two complete sets of sensors ensure full redundancy. Typical accuracy of temperature measurement is plus or minus 0.2 degrees centigrade above the range minus 165 degrees centigrade to minus 145 degrees centigrade. The total gross number of cubic meters of cargo in the tanks before and after loading or discharging is calculated using the average level reading from the gauges. This volume is corrected for heel, trim, volume, vapor pressure and cargo and vapor temperatures. The difference between the volumes recorded at the start and end of the operation are taken as the apparent volume, cubic meter, of cargo transferred. During gauging, all cargo systems on the ship should be closed and the shore connections isolated or disconnected. No ballast operations should take place during measurement, and the vessel should, if possible, be on even keel and upright. However, the operation can be conducted with a slight trim if the corrections included in the tank calibration tables are applied. Custody transfer measurement data is normally recorded in the format shown. This reporting format is used before starting operations and at the end of operations. The reports should contain the name of the master, the surveyor, and the chief officer or cargo engineer.